Now let's solve this problem using the dynamic programming bottom-up approach. So I'll create a DP array, and the array index would be the length, and we'll calculate that what is the maximum profit obtained for, of say, length 0, DP1 would be length 1 and all. So let's start with 0 length, right? If there any rod of like 0 length, we can't get any profit out of it. So our base condition for DP0 should be $0, right? So there would be no cost associated with this. Okay, so now let's move on to DP1, which means that what is the maximum cost I can get from a rod of length 1 only. So what I mean here is got rod of length 1. So here we can see that, right? If we have got a rod of length only 1, there's only one way we can cut this rod. I mean, we can't cut it in any pieces because the minimum unit is given as 1. So the price for this would be the maximum price which can be obtained by selling this whole rod as 1 unit only, and it would be $2. Or in other words, we can write it as price of 1, which is $2. So this is the DP, the maximum profit when the rod given is length, and we get the profit as $2. Now let's check for DP2. The rod given is of length 2. Mark it as this. Okay. Now we can cut this rod of length 2 in two combinations possible, right? We can either cut it like 1 and 1, or we can cut it all together like 2 completely. So it means that one combination is 1 1 and other is 2, and I will like this 0. It's just taking the whole rod together. So 1 1, this can be also written because we are using the dynamic programming approach, right? So we can write this 1 1 as first of all, let's check the price. So 1 1 would be 2 into 2 plus 2, $4, $4. And just taking the whole the 2 unit together, it would be $5. We find that this is giving me more profit. So this would be, we have to check that out of all the combinations, what is the maximum profit available. This is the same as what we did in the previous video, that we checked all the combinations possible, and then we found that 12 is the maximum. So similarly, we are breaking this problem into using the bottom-up approach, and we divide it into just using that for what is the maximum profit for just length of 2. And here we found it's 5. Here we can similarly write this as, it should be price of 1, right? Because this 1, we are getting it here, 1, 1. And now we already know from our previous DP that the length of 1 is already, we have calculated as 2. The maximum profit we can get from the rod of length 1 is, we have already calculated in DP of 1. So it can be also written the same statement as DP of 1. Now, this is how the dynamic programming approach is done, solution is done. We always find the sub-problem solutions, and then we store those solutions and then reuse it in the higher level, that at the same way as we are using here. We already found the solution for DP1, the maximum profit available for rod of length 1, and then we reuse it here in DP2, where we are finding at a higher level, we are trying to find by reusing where we have already computed before. And this can be written again as price of 2 plus DP of 0, right? Because DP0, we're just writing it just to come to a common algorithm. Here also we can write it as dp of 0, because here it's like 1, 0, right? So this is how, I mean, we are always trying to like break down these problems and trying to reuse the problems that we have already computed. So in this, for dp2, we found that the maximum combination is 2 and 0 and will give me $5. Now let's check the same using the same thing for 3, and we'll try to reuse whatever we have computed before for 2 or of rod of length 2 or 1 and or 0. So let me take this similar thing, mark it as 3, and okay. Tick box folder, okay. Now for the rod of length 3, we can cut it into 1 and 2. Other ways, we cut it into 2 and 1. And the one other combination would be we take the entire 3, right? So different combinations can be written here. So it's like 1, 2, 2, 1, or 3, 0, taking all the 3 together. And the price calculated would be 1 and 2. So 5 plus 2, the 7. Two plus it would be same. And for 3 also we found this is same. So we can either choose any one of them. But let's try to see the pattern here again, whether we can reuse the solution. We can see that the first index, we can take price of 1 plus dp of 2. Again, we're trying to reuse whatever we have calculated before. We already know the price. And then similarly, I will do price 2 plus dp of 1. And here should be, just copy this, and then price of 3 plus dp0. Right. So price of 1, 2 plus dp2, we already know 7. Now price of 2 plus dp1, price of 2 plus dp1 is again 7. And price of 3, 7 plus dp0 is 0, is 7. So we are actually, why I'm writing this is that we are trying to just formalize that what is the algorithm which we are deriving from all this, the bottom approach that we're doing. We can see that there are various combinations, but now we have to think that if we can reuse the previous subproblems that we've already solved. So that's why I'm just breaking down into a common algorithm, and then we can see that whether we come to the final solution once we do it for dp5. Now for dp for 4, which means that we need to find the maximum profit for 4. So let's see the combinations possible. Again, we can have 1 and 3. Other could be 2 and 2. Or we can use 3, 1. Or we can take the entire one. So when we are dividing this here, right, when we do 1 and then we try to find what is for the remaining 3, we've already computed that what is the maximum profit for the rod of length 3. So we can use dp3 here. So price of 1 and dp of 3. Then we try to cut this for the second price. For the length of 2, we do it for 2. And then we see that whatever is remaining for dp, which we have already calculated for 2, is 2 here. Then we take the third price, which is less than 4, which is 3. So we take the price of 3 here, this one, and we take whatever is left over, and we have already calculated for dp1 is already created, so we take the dp value of here. And similarly for 4 is equal to 4, so we take the length of 4 price, and then we take that 0, dp0, which is already 0 calculated here. So this is how we are breaking down this problem into an algorithm. So if I write this here again, so as we discussed, we had done 1 and 3, which is price of 1 plus dp3, 2 and 2, which is price 2 plus dp2, price of 3 dp1, and price 4 plus dp0. And if we calculate this, price of 1 is 2 and dp of 3 is 7, should be $9. Price 2 is 5 and dp2 is also 5, so it's $10. Price 3 is $7 and dp1 is 2, that is $9 then. And price of 4 itself is $8. So we found that the rod of length 4 would be having the maximum profit of $10 if we cut it into 2 and 2. Now, finally, we do it for the main, the problem that we have got of rod of length 5. Now, for DP5, we do the same thing as we had done in the previous approaches. So we can cut it into like 1, price of 1, and then DP of 4, which we have already calculated here. And other way would be cut it into price of 2, length 2, and then take the DP of 3. Other would be taking the price of length 3 and taking DP of 2. Or we can take price of length 4 and DP of 1. Or finally, we can take the whole DP as 5 and then remaining 0. So just let's put the same thing as we have done here. Should be 1 and 4, 2 and DP of 3. We already cut it for 3, and 3, 2, 4, 1, 5, and 0. So again, it would be quite similar. I'll just copy from here and price 1 and DP of 4. Then price, I'll just copy it completely here, and DP of 3, price 3 and DP of 2, price 4 and DP of 1, and price 5 plus DP of 0. Now price 1 is 2, 2 plus DP4 is 10. Let's calculate it quickly. $12. Price of 2 is 5 and DP of 3 is 7, again 12. Price of 3 is 7 and DP of 2 is again, this is again 12. Price of 4 is 8 and DP of 1 is 2. Okay, price of 4 is 8 and 2, 10. Okay, then it's 10. And price of 5 itself is 10. So we found that this is the maximum. And this is our solution, which is matching what we did before. So again, let's revise this algorithm again. So here it is that whatever the length is given here, n is equal to 5, we start with the first pair of combination from starting from the length of 1 to the 5 and take all the prices given there, and then we keep on calculating the next the DP of the remaining index array. For example, if this here is 5, we start with price 1 and take DP of 5 minus 1 is 4. Then we take price of 2, 2 is less than 5, and then we take 5 minus 2 is 3 and DP of 3. So this is the algorithm that we have just derived by using this approach. And in the next video, we'll see that how we actually implement this same in Java.